talk about these tropisms first, and then I'll make another slide that each of the guys contributed to that, which was a thing that we looked at yesterday. Phototropism is when a plant grows in response to light. And just so that you know, tropism refers to growth. So when you see that piece of the word as part of the word in biology, it's talking about growth. If you find speaking bio-20, we'll talk about trophic levels, and that's where you are in the food chain, so how you acquire your energy to grow. So phototropism is growth in response to light. Now, it could be positive or it could be negative. And you'll see that there's a question that asks you about that in the review questions. Positive means that you grow towards the light. Negative means something grows away from the light. And what we'll see is that when we talk about phototropism, we're always talking about the stem of the plant. So the plant stem has positive phototropism. Other parts of the plant, like the roots, grow away from the light, so they have negative phototropism. And we'll mention the roots below when we talk about gravity. Now, what happens when light rays hit the plant stem is that light causes a hormone called auxin to migrate, which means to move, to the opposite side, the shady side. So what's actually going to happen is that the side of the plant that's facing the light is not the side that's going to grow. This hormone stimulates cell division, aka we're reproducing cells. So the shady side of the plant will start making more cells. The result is that the shady side of the stem grows faster than the light side, and that makes the stem bend towards the light. Now, gravitropism is growth in response to gravity. And again, you can have positive or negative. Roots have positive gravitropism. The stem has negative gravitropism. So the stem grows away from gravity. The roots grow with gravity. A cool thing is that no matter which way you place a seed, roots will always grow there. So even if I took a plant and flipped it totally 180 so that the roots were facing up, you would bend and start growing downwards again. Pigmentropism, I mentioned briefly before when I talked about vines that can climb, but pigmentropism is growth in response to touch. And there are some plants that have stems that will only grow in the direction of contact. So a really good example of that is any sort of climbing vine, a plant that will grow up the fence or grow up the side of the building on the trunks. Those plants are both growing in response to touch as well as in response to light and gravity. Would anybody like to ask any questions about either of the other two types of tropisms? That's a good question. Now, pigmentropism is not visible in all types of plants. Not every plant does it, but all plants would exhibit those two things. Now, sometimes phototropism, like I said, isn't as obvious because the plant isn't visibly bending, but it's happening. Plants are always growing towards the light for the stem and with gravity for the roots. Does anyone else have any questions that they would like to ask about any of those tropisms? So I asked everybody yesterday who was here. I asked everybody who was here yesterday to think about three guys: Darwin, Boyce and Jensen, and Wendt. learned yesterday, in a few minutes when we spend some time doing review of your own decision, there are two websites that I posted on our Google Classroom page. The first one has a nice animation that shows you how phototropism works, and the second sums up the experiments that these three guys performed. And so I'm just going to be brief. I'll tell you what they discovered and basically how they discovered it. The Darwins, which is actually Charles Darwin and his son, were the ones who discovered that the tip of the stem must detect light. That is what they discovered. So that is their big contribution. Now, how did they do that? They did some experiments where they covered or cut the tip to prove that if the tip could sense light, the plant would go towards the light. And if it could not, the plant would not. So what they did was in some of the trials, they covered it with something that was opaque. In other trials, they covered it with something transparent. And they found that if they covered the tip with something transparent, the light could still get through, the plant would still go in the direction of light. If they covered the tip with something opaque, then the plant would not grow that way. If they cut the tip off, the plant would not grow in the direction of light. They also did a couple of other tests where they covered the lower part of the stem, and they found that that didn't affect phototropism. So the Darwins focused on the tip of the stem. Now, Boyce and Hansen discovered that a chemical substance went from the tip to the stem, and that's how growth was happening. And the way they discovered this was that they did a couple of tests. They took a plant stem and they cut it. And in the spot that they cut, they tried two different things. They tried agar and they tried mica. Just so that you know, agar is permeable and mica is not. So we know that permeable means stuff can get through. What they discovered was that if they cut the stem and filled the space that they cut with agar, phototropism still occurred. If they cut the stem and put mica, the substance that's not permeable, they found that phototropism did not occur. So they deduced that some molecule had to get from the tip to the rest of the stem to make phototropism occur. Now, Wentz, his contribution was that he isolated the substance, and that's how we now know it is oxen. His experiment was not super thrilling. He found a substance and figured out what its structure was. So really for Wentz, it's his contribution that we